Well, I think it's time to make a start. Okay, welcome to lecture 9, I believe, from this term. So it means we've only got 2 weeks left before Christmas. Right, before we get going, I've had a request to go through the 4th task for the current assignment. Now, the 4th task, if you've watched the lecture or been to the lecture or listened to the lecture, you'll know what to do. Okay, I can't give too much away because one of the answers is so obvious, staring you in the face, what you've got to do for this, that if I told you, everyone will get 100%. What you've got to do, you've got to make your web pages easier to index. Okay, now, how you do that is going to be based on what I taught you last week. I will say no more than that, because if I tell you any more, I'll give the entire game away on that part of the task. But if you were in last week's lecture, you'll know exactly what I'm talking about. Yeah, a week there. The second part is more interesting. Remember, I showed you how you can add microdata to your web page that Google can pick up when it indexes the page. So you can add things like your name, any dates, any review data, anything which you think is important to the search engine. You can add this information to. But more importantly, Google have given you a tool to test your micro tags, haven't they? Remember, I showed you can pull off a report of your page which tells you exactly what data it's found in your web page. That's how you know you've done the job properly. So if you do that, if you've done that, why don't you stick a screenshot in here in your report to show you've done it? Yeah, it's good evidence, isn't it, to show that you've tested it. So task 4 should actually be very quick and simple and straightforward, just adding a few tags to your pages. So that's the first task. The second thing I'm going to talk to you about is the assignment, the 3rd assignment now. We're 40% through the course. The current assignment's due in, well, that'll be today, won't it? Thought so, yeah. That's due in today. It's 5 to midnight for those who are obviously well ahead of the game. For those who finished it, well done. Those who haven't finished it, about time to start panicking. The third, remember, these are 4-week assignments. I'm expecting what's reasonable for 4 weeks. Okay, so if you're spending loads of time on it, you may be spending a bit too long on it. 4 weeks worth of work, short, sharp assignments through the year. Okay, so don't spend too long on these tasks. Just get the task done as required, move on. Assignment 3 is the next assignment we're going to be looking at. Assignment 3 is server-side scripting. In this assignment, you'll modify your website to allow it to get its content from a server database. So you've done static pages so far where you've hand-coded the HTML. What you're going to do now is you're going to be pulling the data out of a database and generating the HTML yourself using the scripting language and building the pages from a database. The submission date, you'll be glad to know, Christmas is off this year, is the 14th of January. So you've got a week or 2 back, haven't you? You've got 1 week back, and then you've got a week to finish off the assignment. So it's a fortnight after you come back after Christmas, or less than that. Right. Anyone hands in a Word document to their report, I will personally murder them. For the first assignment, it was just maiming. Yeah, at this point it becomes cold-blooded murder now, if anyone hands in a Word document. PDF only, please. If you're struggling to generate a PDF, come and see us join one of the labs this term so we can show you how to do it. You know, get help, come and see us at Sigma. It should be pretty straightforward in 2013 to generate a PDF from a Word document. I mean, some of you, it looks like you've actually just used Google Docs. You've just created a copy of my Google Docs assignment and just filled it in online, which is brilliant. The other thing I need you to hand in is, minus this page. That's your front cover page, believe it or not. Okay? It has a space here. Please use that space wisely. It has another space at the bottom. Please use that space wisely. We've had assignments handed in this time round which still say your name here on the front cover sheet. Seriously. And some left the little curly braces in there as if it was kind of important. So just put your name on there, put your name at the footer. That way if we lose the bits of paper, if we print it off, we know whose work it is on every single page. Right, as before, there are 4 tasks for you to complete over 4 lab sessions. The first task is all to do with databases. There is no scripting at all in this first task. None whatsoever. I repeat myself, there is no scripting. You're just doing databases. And I spoke to your database module leader from 220, who assures me that he covered enough about databases to complete this task without me saying a single word. So bye. But just in case he was lying or blagging me, I'll give you a bit of information on databases. Don't worry. He says you're all experts on relational databases. Obviously a new meaning of the word expert that we haven't come across before. So I'll go through the basics with you, but everything you've learned in 220 is going to be really useful for this task. So please don't forget it. You're going to be using DDL SQL to build tables, primary foreign keys, okay, UML diagrams showing how your tables work together, where the primary keys are, the foreign keys, the crow's feet, all those little bits of database knowledge. Then you're going to import some data from a CSV file to populate your tables. Because if you don't, you can't do the second task, because the second task is pulling data out and not putting data in, which means if there's no data in the first place, it's going to be a very boring website, isn't it? So we're going to be putting data into the database. Second task. In simple terms, you're going to be taking one of your pages which has lists of stuff, and you're going to be replacing the static HTML with stuff coming from the database. You're going to be populating your lists with information from the database. And the column headings, you're going to show you how to sort data as well based on column headings. So if you click on the price column in your content, it'll order it by price. If you click on the title, do it by title, and so on. And then eventually, you're going to pass the ID of the product across to the next page, so you've got a detail page which displays the product details. And we'll cover that next week. Then just before Christmas, my parting gift for you for Christmas is going to be HTML forms. We're going to be adding data to our database using HTML forms. So you might have a little login page. You might have a page to add a review, which would be kind of useful as is a review site. You might add a new product page to your website. And we'll take you through how we build forms and also how we take the data from the form and drop it into the database. So that's before Christmas. That's the last week before we break up. When we come back after Christmas, we're going to cover the login process. So your whole website will be opened. Anyone can use it up until Christmas. After Christmas, I'll show you how to lock things away and hide things and make sure people are logged in before they access your files. You're going to do the work on the creative server, and I'll talk to you about that as part of the presentation. So we are going to be using server-side scripting for the next 4, 5, 6, 7 weeks because you've got Christmas to finish off. This one, we're going to look at databases, only databases. We're going to look at how databases relate to websites. We're going to look at the factors of how you choose a database. We're going to interact with the database using command line tools. Have you all done SQL statements? The only way you've got to interact with this database I'm giving you is typing SQL statements or pasting SQL statements in. There's no graphical interface at all for this. So what you learned in 220 was obviously of some use. We're going to be using data definition language to design and build our tables. So we've got our tables with our primary keys and our foreign keys and our data types and so on. And we're going to import the data into those tables. So by the time you get to this time next week, you will have some tables populated. You're probably looking at least 3 tables, I'm guessing. You're going to have a products table, aren't you? Possibly a categories table, a reviews table. Okay, what else do we need there? Maybe a users table to store user data. But when we get onto the following tasks, I assume that you've built the database ready to go with some data in it. So it makes the other tasks much quicker to complete. I put a link on Moodle called videos or something, I can't remember exactly what I called it. And that contains some little screencasts of how to work with the tools I'm expecting you to work with. So if you get stuck, there's 4 videos on there. Working with Secure Shell, editing files with Nano, importing data, working with the screen tool, which is kind of cool, and how we work with data definition language, how we build tables. So the screencast there ready for you when you get onto the lab. Now, I had 3 options here. I could teach you everything you need to know about SQL. I could teach you absolutely nothing because you're doing 220 and assume that your knowledge of 220 stayed up there somewhere. Or I can compromise somewhere in the middle and give you the kind of a quick summary of what you've done in 220 and give you a bit of direction. So I'm doing the 3rd option. SQL is a language for databases. It's an ISO standard, which basically means every database, apart from Access, understands the same SQL statements. So if you write your SQL statements for MySQL, which we're doing in this lab, and then suddenly you go to a job and they're using Oracle or MS SQL, you can literally use exactly the same statements and run them on the new database. It's all completely standard. Now, there's some different elements to SQL. There's queries, predicates, clauses, and statements. Queries, when I talk about a query, it means I'm retrieving data. It generally starts with the word select. So just clarify my terminology. If I talk about a clause is a condition where ID equals 5, where name equals Mark. Yeah, that's a clause. Predicates we'll ignore for a minute, and statements are any SQL statement. Inserts, deletes, updates. Yeah. It means the language, as in my language I'm talking to you about, the terminology. Perhaps the word terminology might be a better option for that one. Note to self, it's terminology next year. Okay, it's terminology. So it's the language I use to describe the SQL language. So it's a bit of a sort of self-descriptive thing. Now, we break SQL statements. Right, I need an indication, have you covered this in 220? A unit dedicated entirely to databases. Okay, shall I stop worrying now or after the lecture? 50-50, okay, we'll go 50-50 on this one. Now, all SQL statements can be broken into 4 groups. And we use these acronyms a lot, and businesses use them a lot. The first one is data definition language, which is anything used to define tables. Create table, drop table, modify table, index, all the things to do with the structure of your database tables. So when I talk about data definition language, that's what we're going to be doing in the labs this week. We're going to be defining tables, the fields, the data types, the primary keys, the foreign keys. What we're going to be doing next week is data manipulation language, DML. Things like insert, update, yeah, delete. What's the one missing? Select, delete, update. What's missing? Modify. Okay, so can you see that's data manipulation language? CRUD stands for create, retrieve, update, and delete. They're the 4 operations you normally carry out on databases. Create records, retrieve records, update records, and delete records. So you come across CRUD a lot, which I'm sure you have in this university. Data control language is about permissions. Grant, revoke, they're data control language. I've already run those commands, that's how you've got access to a database in the first place, and you can carry out commands. So for this module, data control language is not important. For next year, for 305, when we're building our own servers and our own systems, we'll teach you about data control language at that point. The 4th one is transaction control language, which is all about if you've got an instruction to update multiple tables or do multiple things, you can bundle them together as a transaction. And the idea of a transaction is either all the statements run or none of them run. So let's imagine you've got your bank account and you're transferring into that bank account over there. You'd have one which is modify your bank balance, wouldn't you? And another one to modify that bank balance. You want them both to succeed, don't you? Because if yours works and this doesn't, the money's disappeared somewhere. If yours fails, then that's not going to work, is it? So the idea is you have what's called a rollback, where you start a transaction, you run some statements, and if anything fails, it rewinds back for you and undoes all the changes. So transactions become very important next year. So this year, DDL and DML. Next year, DCL and TCL. Okay, that's nice and easy, isn't it? 2 for this year, 2 for next year. So we're going to be using 3 statements today in the labs. Only 3 SQL statements are required. Create, to create a table. Drop, to delete a table. By the way, once you run drop, there's no undo. If you've got a table with 10 million records and you type in drop table users, it's gone. It's finished. So we're also going to be talking about next week about how you back your systems up, how you back up a database. That's obviously very important. And drop and alter. So alter allows you to add columns, remove columns, change the data types, change the structure of your tables. And create and drop creates new tables and deletes the old tables. So why am I standing here in front of a Modern Web 1 module talking about databases? Well, fundamentally, almost every database you see on the internet is data-driven. There's some data somewhere in the system. And if we're doing that, we need to store the data somewhere. And the tool that's best optimized for storing data is a database. So behind 99% of websites, there is a database of some sort. So you need to understand how to work with databases. Now, sometimes you get web services, like Flickr API and Facebook and Twitter, all these APIs you work with. So you're working with an API, you're not working with a database. Or yes, you are, because Twitter will have a database somewhere, won't it, storing the data. You're just working with an API, which then stores the data on a different database. So you need databases. And this is the classic setup for the sort of server you'll be working with. This is pretty much what you're working with the labs from this point onwards. A LAMP server, another acronym to take on board and to remember. A LAMP server is Linux, the L, which basically means most servers run on Linux. Most web servers run Linux. I think it's 3 Linux servers to every Windows server out there. So you need to understand Linux servers if you're going to work in web. That's the L. The A is the Apache web server, which we talked about in the first lecture, I think, wasn't it? The bit of software that listens out for people requesting pages and sends the pages back to the user. The M is your MySQL database. Not D for database, M for MySQL, because every Linux web server comes pre-installed with the MySQL database. So you find almost all Linux servers are using MySQL. And they all use Apache because that's the best web server out there. And then the P stands for whatever you want it to stand for. Perl, Python, PHP, the scripting language. The language that actually binds it all together and goes to the database and retrieves the data and sends it through to the web server. So that's a LAMP server. And not only can you access the database using your scripting, you can access the file system. You can pull files off their images and stuff and send them out to the user. Files, Word documents, PDFs. And you can also, there's a mail server built in, so you can send out emails from the server using the scripting language. So most of the time, that's what the LAMP server looks like. And then it talks to smartphones, desktop computers, and so on through the web browser. So you're going to be working with a server called creative.coventry.ac.uk, and you all got a login for it. And I'll talk to you about the logins when we get further in there. So this is what you need to be able to do. If you're going to be a web developer, this is your skill set. You need to be able to create a database over a remote connection. I'm not going to let you into the server room over on the other side of the university to build this, to build your databases. You're going to connect over an encrypted link between your computer and the server that's over on the other side of the university, and you're going to do all your work over an encrypted link between the two. So that's the first thing. You need to be able to create, modify and drop tables over this encrypted link. You need to be able to bulk import data from CSV files and other sources. You need to be able to back up and restore databases as part of your admin duties, and understand how to the CRUD syntax, create, retrieve, update and delete. That's what I'm covering today. So popular databases. There's your choices basically. MS Access, not really a database. Technically it's not a database, it's a spreadsheet with a front end that understands a bit of SQL. And it only allows one user. So if you use Access for your database, if you have 2 concurrent users on your server, it'll crash the database, which is not going to work, is it? It's not scalable. MS SQL, the Microsoft big database, awesome, brilliant. Integrates fantastic into corporate systems, Microsoft world. Bit expensive. Yeah? It costs money. It costs money to buy the server package. It costs money to update every 2 years. It costs money to even have client access licenses. So let's imagine you've got 50 users at the same time on your website. You'd have to buy 50 client access licenses from Microsoft. And they're about 50 quid a pop. If you've got 1,000 people on your site, at the same time, you've got to buy 1,000 licenses. So it's not worth, for internal stuff where you know how many users you're dealing with, MS SQL is an awesome database. For web stuff, it doesn't really work, does it? What we want to do. Oracle is brilliant, no client access licenses. Bit expensive, I think it's $30,000 per server to run Oracle. Okay, but Oracle is used by people like Orange and O2. You know, every text message you've ever sent is stored on a database somewhere. Think how many billion of text messages are sent every day. They've all got to be stored somewhere. And Oracle is infinitely scalable. They guarantee you can build it as big as you can ever want it, and bigger still, and it will never run out of steam. Obviously, assuming you've got enough servers. So Oracle is the big boy. That's the, you know, if you've got a huge corporation with billions of records, that's the one to go for. SQLite. Everyone's got a smartphone. It's got a relational database built into their phone called SQLite. It's great. It's fine. It's a bit like Access. It's a single file database. You know, each database is a file. But the problem is, it's not very good at multi-threading. There's no security on there, and it's not designed for multiple uses. So we're left with one database, which I look at, which is MySQL. Ironically, it's owned by Oracle. They own MySQL. It's completely open source, completely free, and it comes on almost every server that exists. Okay. So I'm going to ignore those slides. Secure socket shell. This is how you're going to connect. This is your encrypted connection between your desktop computer and the server. This is the important bit. If you don't get this bit, you can't do any of the work for this lab. The Secure Socket Shell, SSH, is a Unix-based command line interface. We're connecting to a Linux server, so we use a Unix-based interface. It's used by web admins to control servers remotely. There is no graphical user interface at all. Because if you run a graphical interface, you've got to spend the processor, your server has to support it and run it and maintain it all the time. And you could be using those processing cycles to serve clients, pages. So it's a bit of a waste of time. Most web servers do not have a graphical front end to them because it's a waste of resources. And when you connect through a secure shell, it's secure, it's encrypted. So you're asked to agree to a certificate, and it does a public-private key encryption-based security, like a little padlock in your web browser. And the reason you have to know about this is not because I'm a sadist. Okay, not entirely because I'm a sadist. It's because often it's the only access you will have to the server when you start working with web servers. There are no other options available on lots of servers. You need to know how this works. This is the lowest common denominator. If they haven't got a secure shell set up, you can just walk away from the job because they've got nothing. It's in a walled box with no network cable, basically. If you're on a Linux or a Mac machine, you access it through a program called Terminal. So if you're on a Linux or Mac machine, you use Terminal. And if you're on a Windows machine which doesn't have Terminal, you have to download this beautifully high-tech modern package called PuTTY. Just look at the icon. It's quality, isn't it? Needless to say, most web admins are on Linux or Mac because the tools are there, they're built in. Terminal PuTTY is a pain in the backside. It's horrible, but there's no alternative if you're on Windows. So, if you're on a Mac or a Linux machine, you fire up Terminal and you simply type in SSH, which is the secure shell client, then your username, and then the name of the server. And that's it. That's how you connect. And it'll ask you for your password, and then you're in. Now, your usernames and passwords, I'll talk to you about in a minute. I think I may have written them down somewhere. If you're on PuTTY, that's what PuTTY looks like. Kind of Windows 3.1. And where it says hostname or IP address, that's where you type your creative.coventry.ac.uk in. And when you click on open, it will then ask you for your username and your password. Okay, so that's how Windows works, and that's the download link. That's what the user interface looks like. That's what you're dealing with. It's much quicker than using the graphical interface because there's some really cool tools to help you out. And also, because you're typing commands in, have you heard of shell scripting? Anyone used Python before? You can automate it by pasting your commands into Python and running it as a Python script. That's how I generate your user accounts. I pull in the text file, I loop through, and I generate the accounts and test them. So basically, because it's command line, it's text, you can simply fire up a Python script, put the commands into a Python script, and hit run. Okay, and that's a really good feature. There are two important features of Secure Shell which you need to be aware of. One is autocomplete. If you're navigating around and you type in the name of a folder, if you press the tab key, it completes it for you. So you can type in the first few letters, press tab, and it auto-completes for you. So you haven't got to keep typing. And the other thing which is really cool is it's got a 50 command history. If you want to run the same command again, you hit the up arrow, and then the command appears. You want the command you did before, you hit the up arrow again. And you should hit the up arrow until you've got the command you want to run, then press enter. Or you can modify it and change it. So it stores the last 50 commands. If I were you, I'd have some notes somewhere, maybe something like Evernote or one of these tools. And as you learn new commands, I'd copy and paste them into a note, into a document. So you remember what they are. So you've got a record. So when you go back, you can copy and paste them out of the document back into your window and run them. A few useful commands. pwd prints the working directory, so that prints the path to where you are at the moment. ls lists the files in your directory. For list, ls minus l, l means L for list, long list. That gives you a detailed list. That's what you saw in that command. Look, you see at the top it says ls-l as the command. And that's the detailed list. The owner, the group, the file size, the date it was modified, the time, the file name, and all the permissions are all there for you. Anyone done Unix permissions before? That rw-r stuff. You not done anything on Unix or Linux before? Wow. Gosh, you're in for a treat. Oh, go back. Right. CD changes directory. So CD, then you put the directory name in, and it changes it to the directory. Forgot mkdir, make directory. CD, change directory. Clear, clears the window, so you've got free space. Tree's quite cool. That's tree. So you type in tree, and it maps all the files out that are in from where you are at the moment. Subfolders, folders, files, and so on. However, if you are on Windows, I've got some more bad news for you. Every computer uses UTF-8 encoding for characters, but PuTTY doesn't. So you get gibberish when you try and run these commands. But if you go to that menu, that settings, window, translation, remote character set, just toggle it to UTF-8 and you'll be fine. Otherwise you get funny sort of weird characters appearing instead of those nice little lines and junctions and things. So tree's really cool. Change password with password. There's a built-in code editor on the server called Nano. If you type in Nano and a file name, it'll either create the file for you, or it'll open the file that's there already. And you can do search and replace. You can scroll up and down. You can edit your code. You can open, save, and that's the Nano editor. Okay, so that's MySQL. So that's Secure Shell. Your usernames, and I didn't put it on the slide, you might need to make a note of this. Your Secure Shell username is your student number. Right? The default password is also your student number. So you can connect to this Secure Shell using your student number for username and password. Once you've logged in for the first time, make sure you change your password. Right? Very important, otherwise people can get in there and delete your work. Now, if you forget your password, there's a special form on Moodle I call the P45 form. Because if you forget the root password and you're a database out and you're a system admin, they'll have to reformat the entire computer. and generally P45 is in the post. So if you change your password, please remember your password. If you do forget it, expect a bit of a verbal bashing from me at some point, but there's a form on Moodle to ask for your password to be reset. So obviously we don't want to lock you out permanently, just for a day or two. MySQL database, right, so there I've just logged in to my secure shell, and there's my command prompt. Does not give me much, does it? Tilde symbol and a little greater than symbol. That's all you get, and it's sitting there waiting for you to type a command in. So it's not like Windows where you click on things and randomly drag things around the screen until something breaks. This one, you've got to know the commands you want to type. So to connect to the database, this is what you type in. My username is mtires, that's why I put mtires. Your database username, and I messed this up a little bit, is capital C, capital U, and then your student number. Coventry University. You remember it, won't you? CU, capital C, capital U, and your username. Your student number, rather. The password is also set to capital C, capital U, and your student number for the database. So you type in MySQL, the U, that's called a flag, that little dash U is called the U flag. The dash P is called a P flag. They're basically parameters you're passing into the command. So we're saying, load MySQL, open up MySQL, I'm going to be passing you a username, which is mtires, and the dash P means I'm going to be passing you a password. But obviously we don't type the password here, do we? Because we want it to be hidden. Then it says enter password. So you enter your password, and you're in. Seriously, that's it. And then your prompt will say SQL, will say MySQL, and that's it. So instead of being a little greater than symbol, it says MySQL greater than, and that means you're in MySQL. And it will sit there waiting for the next command. So the first thing you could do is type show databases. And I'll show you that. Well, that's changing your password, by the way, in SQL. So when you first time you log into MySQL, make sure you change your password. And secondly, make sure you write your password down somewhere safe or memorize it. Remember, the login for Secure Shell and login for MySQL are not the same login. So if you change one of the passwords, you're only changing one of the two. You need to change your password for your Secure Shell and your password for your database. And that's the first thing you should do every time first time you log in. Right, so the first thing you would normally do when you've logged into the database is ask the server, what tables do I have access to? What's the table names, what's the database names that I have access to? Because there are hundreds of databases running on the same server. And if I type in show databases, I get this back. Don't be fooled. I've actually only got one database. The information schema basically means I'm mentioned in the information schema. I have permissions set up. That's where it stores all the permissions and the user accounts. The one I care about is the mtires one. And your database will be capital C, capital U, and your student number. Too easy to remember, isn't it? Once I've done that, I have to tell it which database I want to use. Makes sense, doesn't it? So I type in use mtires. That's it. And it says database change, which means it's successful. And now every command I issue is going to be a get on that database. And that's a faff, isn't it? Having to go through those steps every time you log in. There's got to be an easy way, hasn't there? And there is. All you have to do is put your database name at the end of your MySQL run command. So I know it says P flag and then mtires, but actually right at the end, that means use that database. So it says, I'm specifying the username, mtires, I'm specifying a password, but I'm not going to tell you about it yet. And right at the end, I want to use the mtires database. So if in future you use the full command, it means you're straight into the database. Data types I put in there for your reference. I'm not going to go through them. This is an entity relationship diagram. The first part of your assignment, you've got to design your database and show me the tables. This is what I'm looking for, something like this. If you've got Visio, you can do it in Visio. You can use MySQL Workbench, which is a free tool. I've created a diagram in MySQL Workbench. But you can even do it in Word if you really have to, as long as it's got the primary and foreign keys shown with the crow's feet. It's got the database table names, it's got the field names, it's got the data types. As long as it has that information, you can use any program you want. Do it in Paint if you want. Yeah, it doesn't matter, as long as it contains the information. Right, data definition language. We're doing okay. Okay, that's a create table command. Now you've seen that before, haven't you? In 220, you've done this before. Obviously, the key things are not null auto increment, which gives you an auto incrementing primary key. So the server builds a new ID each time. Primary keys mentioned, brackets, commas, varchars, text, int, integer. There's loads of information, including the previous slide on database, on the data types. There's another one, look. The create table syntax. Okay, you see how that works? Same as you've done before. Now remember that module leaders table I built. I've shown you the programs, I've shown you the stuff, haven't I? I need to show you how to do foreign keys, because you need to build these sort of two little foreign keys, the crow's feet. So in programs and programming ID, and staff ID. That's how I build my module leaders table. I'm not sure, have you been shown foreign and primary foreign keys? You've done foreign keys. So in theory, this could just act as a reference then, couldn't it? Use this presentation as a reference tool, just to remind you about the syntax. Foreign key clauses, right, for bonus marks. This is for the high grades, the first and the 2 1s. They offer control over referential integrity, don't they, in the database? Do you understand the idea of referential integrity? If I've got a program leader table and I've got a staff table, if I delete the staff from the staff table, what happens to the link table? Do I delete the records in the program ID? Do I set them to null? How do I handle those deletions and insertions? There are 3 options available. Restrict, which basically means if I have the staff table and the program leaders table, if I try and delete the member of staff and they're in the program leaders table, it won't let me do it. There's still some records in the other table, can't do it. The other option is cascade, which basically means if I delete the member of staff, it'll also go to the program leaders table and delete the records that match that member of staff. And sometimes that's what you want, isn't it? If someone deletes an account with you on your review site, and you give the option of deleting reviews, you might say, well, when they delete the account, the reviews get deleted as well. The other option is set null, which basically says anything which references that deleted record has its foreign key field set to null as a flag to say it doesn't exist. And there's a no action option, which is exactly the same as restrict. Can you see the 3 ways you can handle these cascades? And there's 2 places you have to use this: on delete and on update. That makes sense, doesn't it? Because you can modify a table by deleting the record or by updating the record. Yes? I didn't say that, did I? I said I wouldn't be happy giving that award unless you cover stuff like this, which is not the same thing. Yeah, you've got to show you can do the more advanced stuff. And this is the more advanced stuff. This is proper database. This is sort of commercial level thinking about how your database tables work. So on delete cascade, which means if I delete, I want to delete the records in the module leaders table. If I update it, I want to restrict, which basically means I don't want to update the other table. I want to keep it. I want to refuse to do it if there's a link there. Now, I put this one in, not because I want you to memorize it, but because it uses lots of different data types. So this is a nice example of how to use things like date, small int, bool, tiny int. I've kind of put one of everything in there, so cornucopia of different data types. So if you can't remember how to put the data type in your SQL statement, this is the slide you should be looking at. Okay, so don't memorize that one, and if you type in describe in your database table name, like describe users, describe, what was that one? Describe books. It gives you kind of a fake table like this with the field name, the data type, any keys. You see I've got a primary key and a foreign key, look in there. What the defaults to, and so on and so forth. So it's a nice way of just checking out your database structures. Okay, I'm going to finish off with a couple of simple commands. Drop table programs deletes the table, gone, bang, can't get it back. You can add a new column using the alter table. Add start date date. Okay, there's altering by adding a new column. You can even add foreign keys. If you forget to add a foreign key at the start, you can add it later on by doing this. Alter table, add foreign key, references, and the table name and the field. You can change the data type. So I'm changing my start date from date to date time. Obviously, if you change it from date to date time, it'll add the time to be 0, 0, 0, 0. If you go from date time to date, it'll delete the time part. You've lost it. Just like if you go from a long int to a tiny int, and some values are too long, it'll just truncate. You can change column names. You can change the names of your columns if you wish to do so. You can drop a column. Alter table, drop column module start. And this is how we import the data. What you need to do, you need to create your CSV file on the server. So you've got two ways. You can either create a CSV file and upload it using FTP, or you can literally go onto the server, load a Nano editor, paste your CSV straight into Nano, and then save it on the server, and that's probably quicker. I'll explain why in a minute. What this is doing, we're importing data from a CSV file into the database. So load data local in file, there's my CSV file. Into table, there's my table name. Fields terminated by, it's a comma separated variable, isn't it? Comma separated values. So I've got commas between each of my fields. Optioning closed by double quotes, because sometimes you have double quotes, don't you, around some of the values. If you've got commas inside some of your strings, you have to put double quotes around them in the CSV file. Lines terminated, so each line finishes with a completely recognised standard new line character that everyone uses, apart from Windows. And what you do, there's my CSV file ready to import. It just imports them beautifully. Now, if for any reason you decide to upload a file from Windows, like an Excel file or something, you may say, it will say records created 1. And you think, hang on a minute, I've got 20 rows in my CSV file, I've only got 1 record in my database. Now what's going on? What's going on is Windows doesn't use /n for a new line. It uses /r. Sometimes, but sometimes it doesn't. So if you're doing CSV, I strongly recommend you paste it into the Nano editor and save from within the creative server. And that way you'll avoid all these /n/r issues. Some versions of Excel have /r, some versions have /n. Some versions of the same version of Excel use /r, depending on the service pack installed. So you're in a real unknown situation there when you start to work with things like Excel. Create it in Excel by all means, save it, copy the text out, paste it straight into the Nano editor on the server. Oh, by the way, can you see, because my ID was auto-increment, look at my first column of my CSV file. I don't want to specify an ID because I want the server to give me an ID for that record. So I put null in there, in the CSV file. And what that will do, the server will then generate the ID for it when it inserts the record. Backup and restore. Dead easy. This is done from the secure shell. You do not need to be inside, you shouldn't be inside MySQL for this. You literally log on to secure shell, and from that secure shell prompt, you type in this command. MySQL dump. Okay, that's the command instead of MySQL. -u, you put your username in like you did when you connected to MySQL. -p, yeah, that makes sense, doesn't it? Database name, so it's just like the MySQL connection, isn't it? Then there's a little arrow pointing to the right, or greater than symbol, depending on how you see it. And then you put the name of the file you want to dump the data into, the text file. And it will create a file and dump all the commands it needs to rebuild all your database tables and import all the data that was there. And that's just a text file, which we normally have a .sql extension. Then you can download it onto your local computer, back it up, and if anything goes wrong, you can use the second command. And it's the standard MySQL one now, but this time, after the database name, you've got a left arrow, so data feeding into MySQL, and then the name of the file. And that will restore and it will delete anything that's currently there and restore all the tables and data that was in your backup file. Okay, that's easy, isn't it? But very important you do that on a regular basis. So we've covered, in about the right amount of time, quite a lot today. But having said that, because you're already doing 220, a lot of what we've covered you know about already. This should have been just revision for you, just to remind you how it works. The lab this week is to build your tables and import some data into them. Next week we're going to start talking about server-side scripting and show you how to pull data out of the databases.